Good evening, sir.
Good evening. I think you can start now.
Yes, yes.
Start the session. So our plan is before 23rd, till 22nd, we'll complete the basics. Most of the basics
Yes,
will
yes.
be completed.
We'll complete. Huh?
Then after 27th, because 5 days break will be there, and answer will give some assignments, okay, or exercise you can say. So after 27th, for the next 10 days, from 28th to 5th of June, we'll see some advanced things. Then our workshop will be there from 6 to 11. Then after that only, some mini project will be given, and some experts from the industry also, they are going to give you the hands-on. What they have done, they are going to show you. Okay, so this is the plan. Anyways, now sir, you can start.
Visible?
Can you please repeat everything? You are inaudible. Your network is.
Yes, audible.
Sir, your voice is a little bit breaking. So
My voice is breaking.
Yes, sir.
Okay. I think some net issues will be there. Anyway.
Okay. So my screen is visible.
No, sir.
It's not visible. Okay,
No.
Check again.
Share it again. It is coming.
Now it's visible?
Yes.
Yes. Oh, okay. So let's start today's session. In the last session, we have discussed the NLP pipelines. First two parts. First one is data acquisition, and then we have discussed the data cleaning. Today we will start processing, which is for our NLP task. So, as you already know, we have covered the data acquisition part, the cleaning part, text cleaning part is already covered. Now, this and processing are generally combined together, and we call it as pre-processing. But text cleaning is only essential when you are collecting data, means for creating your data set. But if your data set is already available and you have to use the data set, then only thing you need is the text pre-processing. And in pre-processing step and in text cleaning step, some of the techniques are common. Okay, we'll see some of what are the common techniques, but still these common techniques will be applied here also in pre-processing, and this is the very vital part of this NLP pipeline. Once you clearly understood that what pre-processing steps we need for a particular NLP task, and accordingly you do the pre-processing, then your data will be cleaned. Then the further steps will do not have much means problematic, because if your this process is not correct, then whatever data you have, if you use these data in further processing steps, and today we'll cover some, and next tomorrow we'll cover rest. So let's start. So what is text pre-processing? Very simple, that it is the very crucial part of your NLP application or development, and basically its job is to improve the quality of the text. And before applying any NLP technique on that, you need to improve the quality or clean the text, so that easily you can apply the NLP techniques, and whatever technique you are going to apply, that will be beneficial, that will give you good result. And why we need it? There are different reasons why we need text pre-processing. First thing is that it will improve the quality of the text. Second, it enhances the accuracy. Accuracy means if you have a clean and well processed text, that clean and well processed step, if you use in NLP task or applying any NLP algorithm, then you will get more accurate result. Without pre-processing, if you apply on the uncleaned text, that any NLP technique or any NLP model, then whatever result you will get, and after applying the pre-processing step, if you apply the NLP models, then the accuracy will be much more enhanced using pre-processing. That's why pre-processing is very important. Number two is that noise means of the data in your text is not relevant for a particular task. And mind it, when I say that not relevant for a particular task, that means some data are relevant for a particular task. The same data may not be relevant for other tasks. So wherever it's a task specific job, wherever you find that these data, these kind of data are not required for my task, then you can remove them, because they will create means problem in future application of your NLP algorithms. So to reduce the noise, what you will do, all the irrelevant information, for example stop word, we will discuss what is stop word. So generally sometimes in some applications stop word is not required, so you have to remove them. So that will reduce the noise, and only it will focus on the meaningful content for that task. Okay. Number three is that facilitate consistency. What does it mean? It means there are many normalization techniques. Some normalization techniques we have discussed in your text cleaning part. Here also same kind of normalization techniques we are applying here in text pre-processing. Why it is required? Because sometimes similar kind of data or same data may be present in different forms, and if you will not convert them into one form, then it will unnecessarily increase the vocabulary size, which will lead to other problems. So that's why normalization is very important, and your pre-processing also facilitate this normalization. Okay, which will, if you apply the normalization techniques, it will ensure uniformity in the text data, and that will give you better understanding during the analysis phase. Okay. Next is improves training efficiency. Training efficiency means if you will have less amount of words in a particular data set, then your dimensionality will be less. And if you have less dimensional data, then what will be the benefit? Benefit is that it will be processed quicker by your model or by your computer than the dimension. If a data has more dimension, dimension is here I am directly relating it with the number of words or number of text. Okay, so for that, if you pre-process them, what will happen? Now these pre-processed text will reduce the dimension, and the complexity will also going to be reduced, and it will speed up the training process. Next is it boosts model quality. So if you have a clean and standardized data, then obviously the quality of the model will be good, and it will give you accurate language patterns. Okay, to learn these accurate language patterns. And lastly, it mitigates the bias. If any bias is there in the data set, if you pre-process them, that biasness will also going to be removed. So what is our objective here? Now we need that clean text, because clean text gives better insights and it will create smarter models. And pre-processing turns your raw text into reliable data that powers high performance NLP systems. So that's why pre-processing is very important. Okay. Now let's see what are the types of pre-processing. Basically, I have divided all pre-processing steps into two categories. One is a very basic pre-processing steps, and most quite often you will going to use it. Another is advanced pre-processing steps. And all pre-processing steps I have not mentioned. Most of them I have mentioned here. So let's see what is basic pre-processing steps. So in basic pre-processing steps, I am dividing it into three subcategories. One is preliminary, second one is frequent steps, third one is some other steps which are not that much frequent. Preliminary step is very important, that is called tokenization. So we'll discuss what are the tokens. There are two kinds of tokenization. Tokenization is converting the total text into tokens. Okay. So tokenization can be sentence tokenization or can be word tokenization. This is the first step. And some frequent steps like normalization. So normalization includes lowercasing, expanding abbreviations, spelling correction, then removing digits, punctuations. Okay. Then removing URLs, chat word treatment, stop word removal, handling emojis, stemming, lemmatization. These are some frequent steps. And all these steps, remember, all these steps are not going to be applied for every NLP task. Whichever is required, you just apply. But you have to know that these steps are available. And how also we'll discuss when we'll do the hands-on, we'll discuss some of them. And other steps are like language detection, code mixing, transliteration. Some other, these are some other steps which may require, and they are very not that much very common. Whenever a specific task is there, then for that task it may be required. But advanced pre-processing steps, when we need to do some let's say translation task or summarization task, then these kind of advanced pre-processing may be necessary. One is POS tagging, another one is co-reference resolution, third one is NER tagging. POS tagging we'll discuss. POS tagging is called part of speech tagging, which is nothing but you add one or you tag one of a particular text, whether they are a noun, verb, adverb, or what are the part of speech for that word. Second is co-reference resolution. Co-reference resolution means when a sentence is given, let's say Ramo is going to school and he is a good boy. So he refers to what? It is refers to Ramo. So that kind of resolution is called co-reference resolution. That also you need to tackle automatically by this pre-processing step. NER tagging, named entity recognition. Named entity recognition is you just detect and classify what are the named entities, like name of people, name of organization, location, dates, amounts. These things need to be tagged so that they will have some much more information, not only the word but also these information will be there, and that will help in some of the tasks. Okay, so these are all pre-processing tasks which will transform the raw text into clean, structured, and meaningful data, which will improve the performance of the downstream NLP task. And we will discuss one by one some of these techniques today. So first one is tokenization, which is very basic. This is the preliminary. Tokenization is what? Tokenization means is the process of splitting text into smaller units, which we call as a token. The token can be a word, the token can be a sentence, and the token can be a, nowadays the token can be a subword, character, anything. So that means in a general NLP task, when I say token means generally we will deal with the words, but sometimes sentence can be called as one token. That's why there are two kinds of tokenization here we are going to discuss. One is sentence tokenization, second one is word tokenization. But nowadays when we are dealing with LLMs, so LLM are not using either of them, word or sentence. They are using subword tokenization. Okay, like byte pair encoding algorithms are there, some sentence piece algorithms are there. So here only we are going to discuss only these two. When we will discuss the advanced part, at that time we will discuss the byte pair encoding, which is a subword based tokenization, and all the LLMs, almost all the LLMs are using that tokenization. Okay, so what is sentence tokenization? Sentence tokenization says that you have a text. What you do now, you split that text into sentences. Okay, and individual sentence will be found out. For example, you see, let's say this is the text that Dr. Indu, an expert in AI, visited Chennai. She gave a talk on PhD research at IIT Madras. Her presentation was insightful. For example, she discussed various algorithms. After the event, we went to Marina Beach for a relaxing evening. Now you see, this is a text, and this text contain multiple sentences, and you need a sentence tokenization. What it will do, it will identify what are the sentences, and we know that sentences are basically completed by a full stop or a period. So if you identify the period, then you can split it. But there is a problem is that you see here, after dr we have a dot. So if you just split using split function, if you just do that, split the text with a dot, then wherever you got the dot, it will split it into two half. That means if you directly use the dot as the parameter to split, then what will happen? Dr dot, it will become one sentence. Then Indu up to next dot, it will become another sentence. But that is not required. So that's why it is very challenging. So sentence tokenization, the challenge is that sometimes you have to need to find out which punctuation is actually the sentence boundary marker. Sometimes dot can be a boundary marker, sometimes question mark can be a boundary marker. So you have to identify. And if you say that dot, and dot is very crucial, because dot can be used in many other places besides the sentence boundary. So here what you need to find out, that which dot is actually a sentence boundary and which dot is not actually a sentence boundary. If you can find out, then easily you can get the sentence tokenization. And the challenge is here to identify which punctuation mark is the sentence boundary. Okay, for example, here like I'm telling you that dr phd dot then d dot. So if you just blindly use that dot is the sentence boundary, then this can also become two sentences. Ph dot is one sentence, d dot will become another sentence. But it is not, it is a abbreviation where dot is there. Okay, and another challenge, same challenge, is that differentiating between periods in abbreviation and sentence boundaries. That is very difficult to find out. Okay, and dealing with sentences that include quotations or parentheses. Sometimes this is also another challenge, that you have quotation mark, inside the quotation mark you have a dot, but this is a part of another sentence. Now in that case, when I say that sentence will include that quotation mark sentence. It is not excluding that. If you just use a dot, then what will happen? This dot within the quotation will become another sentence, which is not required. Okay, so these are the challenges in sentence tokenization. And very simple, what is sentence tokenization? Now you have a text, you have to find out the sentences or split the whole text into sentences. And how to get that? Now we need to find out which marker is important as the boundary marker. And always, if a dot, generally dot is the boundary marker, but always dot is not the boundary marker, then you have to deal with that. Okay, this is called sentence tokenization. Second and most common tokenization, what we are also going to use when we'll deal with the encoding or embedding, that is called word tokenization. Word tokenization is what? It is the process of splitting the text into individual words. For example, you see here, this is a text. In the previous chapter, we saw a quick overview of what is NLP, full stop. Now, if you want to find out the word tokenization, in is one word, thou is one word, and you see here, comma is also another word. It is not part of chapter. Now, again, this is again challenging. Now, you see here also in the previous chapter, we saw a quick overview of NLP and something is written here. Now, you see, comma is not part of this word. NLP is one word, comma is another word. You see here that what I need here NLP is one word and this comma is another word. Now, if you use space, and very simple, we have a split function, we can use space as the marker. If the space is there, then it will split into words. But all space is not going to give you word, because you see here NLP, and between NLP and the comma there is no space. So that how will get that? Okay, this is challenging. Sometimes what the other challenge is that, suppose in a email address or URL, so the words are again all are combined. So, but this includes many words. So, how to identify that? What are the words available in them, and what are the tokens? Okay, that is also challenging. Another is that when in English we have shorthand notations like I, comma am. So that is I am. So if you just create the that what your word tokenization, what it will do? It will convert I is one, this apostrophe is one, m is one. So m, and here we are comma sorry, apostrophe is re. So re will become another word, but rem, they are not meaningful words. So that is the problem. So with the word tokenization. So, but you see how we'll implement it. Now we know that many NLP libraries like NLTK, Spacey, they have their own implementation. Okay, so for in NLTK we have two methods for sentence tokenization: sent underscore tokenize, and for word tokenization, word underscore tokenize. Just call this method, pass the text, it will automatically return the return this list of tokens. Okay, but what is the problem with them? It's not perfect. While these readily available solutions work for the most of our requirements, but it's important to find out they are not perfect. Now you see there are two examples I've given. If you use NLTK's word tokenization to tokenize the word, then let's say this is my sentence. Mr. Jack O apostrophe Snell works at Melitas mark, and so is located at Austin 70272. If we run this through the NLTK tokenizer, what it will do? It will create this O apostrophe nil into 3 tokens. Okay, but it is one name. So here you have to again understand. Sometimes comma is not part of a word. Sometimes comma is part of a word. Sometimes apostrophe is not part of a word. Sometimes apostrophe is part of a word. So that is very difficult to find out. Now here this is a part of one word, because if you make it 3 words, then its meaning is totally gone. O means what? We don't know, because this O nil, it is one name, or it is a part of a name. So this is problematic if you use NLTK's available library. Similarly, here you see there is another sentence. There are dollar symbol, then 10,000, and pound symbol, then 1,000, which are there just for testing a tokenizer. So when you run on this text, your NLTK's word tokenize, what you will find, now this will segregate dollar and 10,000 into 2 different words, but it is not going to segregate this pound and 1,000. Pound and 1,000 is one word. So again, it will be difficult for the model to understand whether this one is here, one symbol is there before a number, but this symbol is separate. So whether it is a dollar symbol is representing the currency or something else, it is difficult to understand by the model in future. That's why this is very important, that when we are going to use any kind of tokenizer, always remember that the inbuilt or pre-built tokenizer are not always perfect. Sometimes if your sentence is very simple, and you have already seen the data set that these sentences do not have such kind of problem, then you can use your existing tokenizer. Otherwise, what is the what you will do? You have to create a custom tokenizer for your pipeline. That means you identify what may be the problem. If this kind of problem is there, then you need to create your own tokenizer. Don't only depend on the available tokenizer in the library. Okay, so these are the 2 tokenizers. This is the first step or basic preliminary step of pre-processing. Question may be there, that why we need to tokenize? Because tokenization is not directly related to cleaning or modifying the text, raw text into clean text. Tokenize is just to segregate. Why we need it? We need it, this tokenization, because this is required in the second step, that is embedding. When? Because we know that our ML models, which will be used for creating NLP models, is not going to take these words. So they need to be converted into numerical form. So that part is called text representation or embedding. So for creating embeddings or numerical form of the text, we need to tokenize. That's why tokenizer is required. Is it okay? Okay, so this is the first basic preliminary step. Second, that which are, so there are some frequent steps which are there. Some of them may be required in some tasks, some of them may not be required, and let's discuss one by one. And for all the tasks, we combine together to call it as normalization, because we need to clean the text into a good formatted text. So what is normalization? Normalization already we have discussed in cleaning. Some of the normalization techniques are also here. Okay, so it involves converting text to a standard format like lowercasing, expanding abbreviations, and a spelling correction. For example, you see here, he is a PH.D. students. Now, if when you apply these normalization techniques, it may be converted into he is a PhD student. All are in small letter. There is no punctuation. That dot we have removed. Like here, EG, approx, etc. So they are abbreviations. They will be converted into, for example, EG will be for example, approx is approximately, etc. is etc. So it will be etc. Similarly, receive the opportunity. So as it is already there in the correct form, so it will return as it is. Okay. Uh, here spelling mistake is there, so that spelling correction will be done. Okay. So that means for normalization, what are the basic steps, basic challenges? There are the 3 challenges. One is handling variation in spelling. That sometimes you see the mix of spelling, the both are correct. One in British format, they like say you see this favorite and favorite. This is a British English, this is American English, but both meaning are same. But if you find in a text that both are there, then your model will treat them differently, but they must be converted into one format. So that variation need to be changed. So that is one challenge, how to deal with that. Another one is abbreviations. Sometimes you will see this kind of ASAP, TBH, ROI. So they need to be treated so that their appropriate sentence or the corresponding words will be converted. Okay. Similarly, spelling correction. So let's see one by one what are these techniques which are frequently being used. First one. First one is called lower casing. So lower casing, what is it? It is a very simple process of converting all characters in a text to lowercase. Sometimes people are not using lower casing, you can also convert it into upper casing. But lower casing or case folding, which is basically folding to lower case, is common in NLP tasks. If you need, you can, if you say that no, I will convert them into upper case, that is no problem. But most of them are following this standard that all should be converted into lowercase. So this what it will do? It will standardize the text data, and by eliminating the case differences, and which will give you a uniform analysis. You see why it is required, because in our English language, particularly in English, in other languages, this there is no lowercase uppercase letter. Only in English it has available. So here, why it is important? Because it will give you uniform representation. Number one, that means it will treat words with different cases as identical, which is crucial for accurate text analysis and processing. Because otherwise, what it will do, if one same word is written in one place, it is written in capital letter, in another place it is written in small letter, then your NLP model will treat them two different words, but their meaning is same. So they need to be converted into one form so that they will be used once, only one as a one word, not two different words. So that uniform representation is very important. Second, it simplifies matching. Simplifies matching. Now it helps text matching and retrieval text. Suppose you have a text retrieval task. That means you give some query, and your NLP task is that it will retrieve the related text out of that query or related to that query. So in query, some words will be there. If the words contain in one case, and your actual document which is there in the source is in another case, then there will not be a match. So what is the best way? That you convert both in one case, then there will be a match and easily relevant document can be retrieved. Okay. So that is one application where you can use lowercase. Another one is improves model efficiency. It will ensure that the text data will be consistent, and same kind of same word will be represented not in different cases, but will be in one case. For example, you see this is an original text. What it says, that the quick brown fox jumps over the lazy dog. So your dog is dog. Okay, but after lowercasing it will become dog. Sometimes if you see this one, you just see this is the start of the sentence in English grammatical way, that the always the first letter of a sentence will be capital. Now if you have the here and this the here, now these two the will be treated as different. If you see here, it is a capital letter T, here it is a small letter t. So but these two the are same. So what we'll do, if you convert them into one case, now these two the are same, so they will be treated as equal. This is one. So that's why lower casing is very important. Okay. um, so it will ensure that the search result match regardless of the case in that for the searching case. Is it okay? So this is the first step. Very simple. You just whatever data you have, you just convert them into lowercase. Second is spelling correction, and spelling correction is required. Sometimes it is required, sometimes it is not required. Okay, but if you want to give some noisy data, you can misspell some of the words to make your system or NLP model robust. But in many cases it is not the case. Like if you are generating some sentence is in a language model, if you want to do a translation in that in these kind of task, the accurate word should be there, the perfect correct spelled word should be there, otherwise they will be treated differently. Okay, so what is spelling correction? It is a simple text normalization technique, and which is used in NLP. What it will do, it will detect and correct incorrectly spelled words in the text. And here the main goal is to convert noisy or misspelled text into the correct and meaningful form so that machines can understand the text more accurately. Okay, and why it is more important? Why the spelling correction is important? Because NLP models depend heavily, some of the models or some of the tasks, it depends heavily on clean and meaningful text, and misspelled words will create problem. You see here, for example, LUV and LOVE, they are not equal. They may be treated as completely different words by MSN if you use these two in a text, but they are same. So you need to convert them. You need to correct them. Okay, so without spelling correction, always remember NLP systems may misunderstand the meaning of the text. How will do that? You see here, there are I will show you how we can do that. There are available some libraries are available. You can use that library and directly it can correct the misspelled task. So here this is I promise, so here spelling instead of M, it is written as N. So after spelling correction it will become promise. Here break, EAK, so here it is written SK, but we will convert it into EAK. Is it okay? So this is called spelling correction. This is the second pre-processing task. Third pre-processing task is called expanding abbreviation. So you see, sometimes in many text you got the abbreviations, and in English also there are some abbreviations which are inherent to the English, like can't. Here I have written can't, CAN apostrophe T. So if you have in a text, if you have all can't is written like this, then there is no problem. But if some are CAN apostrophe and some are CAN NOT, then there will be a problem because both are same, but they will be treated differently. We need to convert them into one format. So that is called expanding abbreviations. What it will do? Now it will, wherever it will find out abbreviations or acronyms or contractions, they are converted to complete standard form. Okay, why it is important? Same, because if you have not do that abbreviation expanding, then what it will do? It can create ambiguity and inconsistency in the NLP processing, and the machine will treat them completely different words. Always remember why we are doing all these kind of normalizations, in order to give the machine that these words are same, not different. If you have same meaning word but they will be treated as differently, then your dimension, your number of vocabulary in the corpus will become more, and the dimension will become more, which will be difficult for processing. Okay, so here you see this is I can't, and it will be converted into cannot. Okay, and we'll see how to do that in program also. Fourth one is called removing punctuation. Punctuation removal already we have discussed in the last RE class. Here also we'll see. So what it will do? Removing punctuation, it is a basically text processing job. What it will do? It will remove the punctuation to simplify the text processing or be further analysis. Punctuation mark, there are many punctuation marks. Some are listed here. Okay, and why we need to remove them? Because sometimes these symbols are not give you meaning to your task. If for your task they are required, then you cannot remove them. If for your task the symbol do not have any requirement or they will not give you any information during processing, you can remove them. That's why it is useful. For always don't remove these punctuation marks. Okay, so here the goal of punctuation removal is to retain only meaningful textual contents. Why it is important? So it is important because punctuation marks can create unnecessary tokens. It will increase the number of tokens. Okay, and increases vocabulary size and during text processing. For example, you see here hello and hello exclamation mark. So it will create two tokens, and they will be treated as differently, two different words. Okay, but we need, if your exclamation mark do not require for your task, then you can remove them. Okay, so by removing punctuation, both become now will hello, and they will have consistency in the NLP pipeline. So this is the original text, and after removing the punctuation, we will get this text. Okay, but question is, can we always remove punctuation blindly? The answer is no. You cannot blindly remove all the punctuation in all tasks. It is task specific, because if you remove the blindly all the punctuations for some important for some task where the linguistic, grammatical, emotional, and semantic information is required, in those kind of tasks, what you will see that they will be lost. Okay, and removing them without considering the task leads to loss of meaning, incorrect interpretation, and which will reduce the model performance for some of the models. Okay, and let's say for which type of model, let's say it is a emotion detection. In emotion detection, the exclamation mark the is very important, let's say, and if you remove them, then you may not get the actual emotion. Okay, so for some tasks like emotion detection or sentiment analysis, you need some of the punctuations, and you have to identify which punctuation is required for my task and which are not required. Accordingly, you have to filter out. Okay, so here it says that punctuation is important in sentiment analysis and emotion detection tasks. For example, you see, I love this product. So exclamation mark. So it shows what it will show. It will show a strong positive emotion about that product. But if I just write I love this product dot dot dot, so it may indicate hesitation or sarcasm. So how will identify? So this punctuation marker are very important in these kind of applications. And if you remove them, then the both will appear same, and it will be difficult to find out which has most positive sentiment, which has not most positive sentiment. So for sentiment analysis, emotion detection, some punctuation are very important. You cannot remove them. Okay. Another important reason is that it will help in sentence boundary detection and tokenization. So if before that, if you remove all the punctuation, then you cannot create a sentence tokenization, because we know that sentence tokenization needs word boundary or the sentence boundary to be detected, and these punctuation marks are very important to detect the sentence boundary. So you cannot remove them. Okay, and punctuation is also essential in tasks such as machine translation, text generation, speech synthesis, because in that case grammatical correctness depends heavily on the punctuation. So you remember, always you should not remove the punctuation. Remove only those punctuation for a particular task which are not required for that task. And if you find that the punctuation mark are required for that task and it is very relevant for that task, you cannot remove them or don't remove them. Okay. So this is the rule that the punctuation processing must be task specific to avoid losing a meaningful linguistic and contextual information. Okay. There is a question: if the word is contd dot 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 like on the top of the page, should we remove the punctuation? Okay. Now here the question is, here in my slide here there is a triple dot. Okay. Now it will depend what kind of task you are doing. Suppose I am doing a text classification job. In text classification, general classification, this dot 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 do not have any importance. You can remove them. Okay, and after removing, you see contd is not a perfect word. You need to again convert them into full word by expanding abbreviation. Okay, and if we are giving a means if you want to process that this one is important, let's say you are doing some kind of translation, machine translation, in that case this dot 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 is important because it will say that this is continuation of the previous slide. Okay, so continuation is required, so in that case you cannot remove them. Okay, because it says that this means that it is continuation. So if you need that information, then you should not remove. If you don't need, remove them. Is it okay, Anurag? Okay. So carefully do the punctuation removing. All punctuations should not be removed. That depend on. So when you deal with the task, it will come to your mind that when you see that this is the task, and when you explore the data set, when you see that, then it will come to your mind automatically that yes, this information is required, we should not remove. These information are not required, we can remove. Okay, that you can decide. Fifth step is a chart word treatment. Chart word treatment abbreviation, expanding abbreviation, quite similar. Okay, but here I am putting them in two different categories. Here, chart word treatment specifically means that those words which are non-English, and we are using them in our day-to-day text messages. Okay, so how will deal with that? So your chatbot treatment means it is a normalization or pre-processing technique in which the NLP where have whenever you got a informal chat words or any kind of slang or shorthand expression, they should be converted into standard and meaningful form. And generally, these kind of data you will see when you do some kind of social media data analysis. For example, let's say you got a movie reviews from Twitter or X. Okay, now these movie review tweets, as they are in the platform of social media, so people will write some shorthand notations, which is very difficult to understand. Now, what is your job? Your job is that before giving this to the NLP task, you need to normalize them, means convert them into its original word form or whatever is the full form of that. Okay, so your chatbot treatment replaces such informal words with their proper form so that the NLP system can understand the text more accurately. Okay, for example, you see here OMG, you are GR8, mean great at NLP. So what you will do? Now these words are not perfect words in English. They are used in our text sorry, social media platforms. So you need to convert them so that OMG will be oh my god, U will be YOU, R will be ARE, great will be GREAT. So you need to convert them. Then only instead of giving this text, you have to give this text for the NLP process. Okay, why it is important? Because NLP models are usually trained on standard languages, and if you got informal chats, then we can create inconsistencies, and it will reduce the performance of the NLP system. So for that reason, we need to convert them into its correct word form. So how we'll deal with that? That also we'll see in hands-on today. Also we'll discuss that. Okay, and basically we will find out them in Twitter analysis, chat, WhatsApp chat analysis, SMS processing, customer support, chatbot analysis. If you got this kind of data in your data set, then you must find these kind of words. So you need to convert them into original form so that in further processing it will be helpful. Okay. Sixth one, this is stop word removal. It is very important. So stop word removal, what it says? What is a stop word? Stop words are basically just to say that they are very commonly occurring words, and they do not have any meaning assigned to them. Rather, they are basically used to express some grammatical information. Okay, and these are called stop words. For example, is, am, are, all the prepositions, and not, on, many, and they do not have their own information. They are only used as a glue between other words. Okay, sorry. So they have little meaning, they have little information. So in many NLP tasks, they do not need. Okay, suppose a simple classification task. In simple classification task, our objective, let's say your objective is to find out whether the text is positive or negative. So here, in the positive or negative, some of these words are not important, like the, is, am, are, and, in, on. These are not required, and they do not have their own information. So they need to be removed because unnecessary it will increase the vocabulary size. So okay. So these are called stop words. Now, if you see, the cat is sitting on the mat. Now, this is your original text. After removing, what it will become? Cat sitting mat. Okay. And why it is important? Why the stop word removal is important? Because in many NLP tasks, stop words are removed to reduce the noise, reduce the size of the vocabulary unnecessarily, and improve the computational efficiency. Because when you reduce the size of the vocabulary, your computational dimensional will be reduced, and that will be give you more quicker computation during training, and it will only focus on the important words. Okay. Now, in this case, you see the cat is sitting on the mat. So important information is cat sitting at mat. They are giving important information. The is on the, they don't have any meaning. They don't give much meaning. They are only used to glue these three words into one sentence, and it will be grammatically correct. So for grammatical correctness, these words are there. Otherwise, they don't have their any other useful So they can be removed. Okay, so we can remove these stop words. What are the challenges? The challenges are many. All stop words you cannot remove. Again, same. All punctuations you cannot remove. So all stop words you cannot remove. Again, it will be task specific. Okay. So one problem is that there is no standard list of stop words. Suppose you got a data set and you have to go through your data in the data set and try to identify what can be the stop word which is not required for me. You have to identify. Otherwise, if you use some predefined stopword list which is available in many NLP libraries, like NLTK has one, so in that case all stopword are mentioned. So if you remove them using that list, sometimes your valuable information will be lost. Okay, I will show you one how. Okay, so sometimes some stop words are very important depending on a particular task. And determining the appropriate stop word list for a particular task or context, like information retrieval, sentiment analysis, topic modeling, is very difficult. First, you need to identify, create your own list, then use that instead of using the existing list. Okay, I'm giving one example here that let's say ensuring important words are not mistakenly removed, like no. In no pen, no gain. So here no is a stop word. But if you see no pen, no gain, and if you remove no, pen gain don't have any meaning. Okay. Then why, when we will not remove them? Let's say another task. If the task involves understanding the context or sentiment, that is a sentiment analysis task. In that sentiment analysis task, you see not is a stop word. If in a sentence you got not happy, these two word is there, and not is a stop word, and when you remove, then what it will become? It will become happy. So negative sentiment becomes positive sentiment. Okay, and in sentiment analysis is not, no, they are very important. You cannot remove them. Okay. Similarly, for machine translation, all stop words are very important. Okay. So you see in machine translation or machine text generation, so you need to retain this stop word. You cannot remove them because you see he is going to the market. This is grammatically correct and meaningful. If you have this, then only when you do the machine translation, you will get a correct translation. If you remove them before machine translation being applied, then it will become he going market. It does not mean anything. It will give you different result, and it will be reduced form of result. So in many cases stop words are required, in many cases stop words are not required. Like in machine translation, all stop word is required, but in many cases some stop words are required, some stop words are not required. Like in your sentiment analysis, so here not is required, but is, am, are, they may not be required, and you have to identify that. Blindly don't remove. Okay, this is the main objective of stop word removal. Is it okay? Now come to the seventh step, that is called handling emojis. So emoji handling we have discussed in text cleaning part. Just replace these emoji with Unicode, but still other handling techniques are there. Let's see what is emoji handling. Now here handling emoji is basically required where emojis and emoticons present in a text and they are processed appropriately so that their meanings can be understood by the machine. Okay, and sometimes the emojis have their own meaning. Let's say it is a same sentiment analysis task. Okay, in sentiment analysis task you got I love NLP. Okay, and then there is a sad face, let's say, so it is a sarcastic comment. If there is a smile face, then it is a positive comment. Now how will I identify? If you remove them, it just say I love NLP. Even if it is a sarcastic comment, you cannot get that without these emojis. So sometimes emoji is very important for particular task. Always you cannot remove. Okay, and people are use emojis to express emotions, opinions, reactions, sarcasm, or sentiment. Example: this one happy face is happiness. This is sadness, love. This is excitement or fire. Now, what are the types of emojis? Removal techniques. There are basically four emoji removal techniques are there. Okay, one already we have discussed in the cleaning part, whereas three will see. One is emoji removal. First one, handling emojis of four types. Emoji removal, just you remove the emoji. If you see that for my task emoji do not have any requirement, you can remove them directly. So very simple. So before that it was I love NLP with smiley face. After removing, I just get the text. This is a simple technique. Another one is emoji replacement with text. So if you do not want to remove them, rather emoji do not give you the information because it is a image, so you can convert them into text. So you see, this is the I love NLP, this happy face. So when you convert them, it will become I love NLP. This happy face will become happy face or happy. So there are techniques available how to do that. Okay, this is called emoji replacement with the text. Another one is emoji encoding, which we have already discussed. What you do, you just find out the Unicode and replace the emoji with its corresponding Unicode. Fourth one is emoji embedding. Emoji embedding is basically used in DL or deep learning based NLP task. What it is saying, like we are converting every text into numerical representation, we call it as embedding. Similarly, directly, the emojis can also be converted into numerical form with some library or some techniques are there. We call it as emoji embedding. So without deleting them, directly the emoji will be converted into numerical form. That is called emoji embedding. But here, what we will do, we will discuss these two: emoji removal and emoji replacement when we will go for the hands-on. Okay, and this thing already we have discussed. So question is why it is important? Because handling emoji is important because emoji often carry uh, strong emotional and semantic meaning. Ignoring emojis may cause NLP system to misunderstand the actual sentiment of the text. Okay, so there is a question: is in emoji replacement with the text, we will not change the meaning of our text corpus, making it difficult to pre-process text. Um, Okay, it's same because when you in emoji replacement, what we are doing, we are replacing that emoji to a corresponding text. So if you do that, the meaning is same. If it is a happy face and you are writing happy face, so now for your task it is difficult to find out the meaning of the emoji. But when it gets text, it can easily represent them in numerical form in embedding, and it can be create. You can get the information during the downline task. Task. Is it okay? Anurag, means emoji, try to understand, emoji itself cannot be processed directly. We have, when we go for the next step in the pipeline, that converting into numerical form, you can only convert the words, you cannot convert the other things like emojis, you cannot convert. Now in that case, very difficult to handle the emoji. So if you are already converted them into text, then it will be easier for the next step in the pipeline. Or if you remove them, then it's okay. Okay, but again, if you remove, you got get lost many different many important information. So depending on your task, you can either remove them or you may keep them. Okay. Okay, so so this is called emoji handling. So here you see, I love this this movie. Here it is a happy face, so it is a positive sentiment. I love this movie, but here it is a sad face. That means negative. You see, both if you remove them here in the sentiment analysis task, try to understand what is the problem. Now I love this movie. Here also I love this movie. But here it is a positive sentiment due to this emoji. Here it is a negative sentiment due to this emoji. Now if you remove these two emojis, then both will same. And it will be very difficult for the model to create a generalized model that it will be confused that in one I love this movie it is giving positive, but I love this movie in another row it is giving negative. So it will be confused. So what is the best way? Best way is that in this situation you convert them into text. So I love this movie happy face, I love this movie sad face. So this word will have meaning. Now it can be easily understood by the system. Okay. So this is called handling emojis. Okay. Now comes stemming. And stemming and lemmatization both are again two very important concepts. And these two are going to be used everywhere, almost everywhere. Okay. So now what is stemming? So stemming is a text processing task which is used to reduce words to their root or base form. How it will reduce it? Now by removing affixes. Affixes means it can remove the prefix or suffix. depending on the word, and it will create a stem or root. We call it as stemming. Okay, and what is the main goal? Main goal of stemming is to treat different form of a word as a single word. For example, you see here playing, played, plays. They are actually three different words, but their stem is play. Instead of using these three different words in your text, if you can convert every word into play, a stem word or root word, then it will be easier for the process, for them to process, because it will decrease the number of vocabulary. But you see, playing, played, play, both are meaning is same. Only difference is their tense, but their meaning is play. So instead of using them are three different words, if you can convert them into one word, so drastically it will reduce the number of vocabulary in your system. Okay, and here stemming, there are different algorithms are available for stemming. It says that the stemming is a very simple algorithm. What it says, that just chop the affix or crude chopping of affixes. Affixes means either suffix or prefix. For example, you see here arguing. So your affix is your suffix, that is ing. So you just remove the ing, chop the ing, you will get argue. Playing, chop the ing, you get play. Flies, you just es, so you get a fly. News, s, just chop the s, you will get new. Okay, but this is the simplest way to get the root form of different words. And why it is and always if you use stemming, it is not a good way to get the root word. Sometimes stemming will give you incorrect root word. For example, you see caring. So caring, its root word is care, but if you just use stemming technique, what it will just chop the suffix, that is ing. When it will chop the suffix ing, it will become car, but the actual root word of caring is care, C-A-R-E. So it gives wrong words. Similarly, studied. Studied, if you see, the actual root word is study, Y. But if you just use stemming, ED will be removed. So it will become STUDI, not Y. Similarly, running. Running, if you remove ING, it will become RUNN. But I need run, RUN. Happiness. Happiness, if you remove ESS, it will become, sorry, NESS, it will become HAPPI. Happy. But it is not happy, it's HAPPY. So stemming is problematic in the linguistic perspective. Okay. Why it is problematic? Because it just chop the affixes, either suffix or prefix, depending on the word. And sometimes it will give you incorrect root word or incorrect word, which is even not available in the dictionary. So, but it is very easy to do. Okay. And why we need it? Same, we need to convert every word into their more multiple different grammatical word into one stem word. And without stemming, this system may treat them as different words, and that will increase the vocabulary size and which will reduce the efficiency. That same problem, due to this same problem, we are doing all kinds of pre-processing tasks. Okay, but there are different stemming algorithms available. Most common algorithm is called Porter stemmer. Okay, so Poto will not discuss the algorithms, rather they are already implemented and the library is available. So Porter stemmer, it is basically a rule-based algorithm. One step-by-step rules are there. When you got a word, it will pass through the rules and accordingly it will chop the affixes and you will get the stem. Okay, another stemmer is called snowball stemmer. So it is the improved version of Porter stemmer. Okay, and it is generally a little bit faster and efficient than the Porter stemmer. Another one is a Lancaster stemmer. It is a very aggressive stemming approach. Aggressive means without looking anything, just chop everything. What is there? And very old stemming technique is called Lovni stemmer. This is the earliest technique. It is basically used to remove the longest matching suffixes. Okay, and mostly we'll use this Porter stemmer. Okay, so here stemming will do what? The stemming will reduce words to approximate root forms to improve text processing efficiency, but sometimes sacrifice linguistic correctness. Okay, then comes lemmatization. This is same. The stemming and lemmatization are similar. Okay, but what lemmatization will do? Here also lemmatization is a same text pre-processing task. It will also convert words into their meaningful base or dictionary form. This is important. Dictionary form, we call it as lemma. Lemma or root, both are same. But here, you will not get any kind of irrelevant words like you are getting in the stemming. Okay. So, like running, it will give you perfect run. It will not give you RUNN. Better, it will give you good. Studies, it will give you study. Went, it will give you go. Okay. And we call this as lemmatization. It will give you perfect dictionary term without chopping anything. Means that is the difference. So now you see, the lemmatization is basically finds the correct base form of a word using some linguistic knowledge like POS tag or some other meaningful context. It will use that and convert them into its correct root form or lemma. And here, why it is required? Because we know that same reason that what we have given in stemming, that one word may have different grammatical forms, all need to be converted into their root form or lemma form. If you use stemming, sometimes you may get wrong words, but if you do the lemmatization, it will give you perfect word. Okay. So that's why stemming is not equal to lemmatization. They are mutually exclusive. Okay. And the lemmatization is a much more resource intensive task, and it will give you correct result than the stemming. But stemming is faster. But the advantages of lemmatization, advantage is that it will give you more accurate than stemming because it produces real dictionary based words. Okay. And it maintains the meaning of the grammatical correctness of the words. But disadvantage is very slower and very complex, and it needs some additional resources. You just cannot give the data and it will give you the stem. You need some additional resources like a dictionary you need, and like a POS tagger. Generally POS tagger is required. Okay. And if you see what is the difference, so here stemming, if you have interchange, interchanger, interchangeable, interchanging, if you do the stemming, it will give you interchange, which is incorrect. But if you do the lemmatization, it will give you interchange correct word. Okay. So if you see, these are the differences. Approach, generally stemming is a rule based approach. It is the idea is just chop off the suffixes, but here it is a dictionary based approach. It uses POS, that's why it gives good accurate stem or accurate root word. Here result is stem, may not be the real word, but here result is lemma. Always it will give you a real word. Speed, the stemming is faster and less computationally expensive, whereas lemmatization is slower and more computationally intensive. Accuracy term, if you see, it is less accurate and may distort meaning, but here it is more accurate and preserves meaning. If you see use case, it is simple. If you need only simple text processing, you can use this stemming approach. But if it is a very important NLP task where meaning is very important, in that case you can use lemmatization. Okay. So the bottom line is stemming is fast, uses a rule-based technique, whereas lemmatization is uses vocabulary and grammar to return correct base form. Okay, so these are the techniques which we have discussed. Is there any question?
Yes, you can unmute and ask the question.
Anyone has any question? So we have discussed all the basic pre-processing steps. In the next class, we'll discuss the advanced part, whatever is there. Okay, or should we go for the hands up? Okay. So let's close this one. Is it visible?
No.
No, sir.
Okay, okay. Now is it visible?
Yeah, visible.
Okay, okay. So whatever we have discussed, we'll just do that. Okay. So first we'll start with lower casing, spelling correction, expanding abbreviation, removing punctuation, chat word treatment, stop word removal, and handling emojis, stemming and lemmatization. The tokenization part which we have discussed first, that tomorrow we'll discuss that. Okay. So for that, what libraries we need? We need regular expression, we need analytical library and a string library. And from NLTK, there is a stop word list is available. Just you need to import that and download it. There is a Potter stemmer, because Potter stemmer algorithm is already implemented for stemming purposes, so we have to import that also. And for lemmatizer, we have wordnet lemmatizer, which is already there. And for wordnet lemmatizer, we need these two things to be downloaded: wordnet and OMW 1.4. And for stop word, we need to download the stop words. Okay, so first we have to execute them. So all the required libraries are now imported. Now let's see how to do the lower casing. Very simple. Lower casing is very simple. I'm giving you two options. One on simple text, another one on a data set. So let's see here. I have a text, that is the quick brown fox. So to and I'm assigning this to the variable text. So to do the lower casing, what you do? Just call the lower function on the text. So text is a string. So on the string, the lower function is available. Just you call it text.lower. On this text, lower function is applied, and this one will become lower, and I am assigning to a new variable. So when you run it, now this quick brown fox will become the quick brown fox with all are small letter. This is for a single sentence or single text. But if you have a data set, data set contains many rows with sentences. How will apply on that? Let's see. So here, what I have done, I have installed a Hugging Face dataset. So to install Hugging Face dataset, you just use exclamation mark pip install datasets. It will install the Hugging Face dataset library. And for that, we don't need any authorization token, because some of the datasets in that library is public. Some are not public. For them, you need to use a authentication key. Okay, and it is easy to find out authentication key. Now for this we don't need. So what I have to do, for from dataset import load dataset. So I imported the load dataset function. Now I am importing or downloading a dataset called IMDb movie review dataset. And in that movie review dataset, you just call the load underscore dataset, pass the IMDb, automatically that dataset will be loaded and stored in the IMDb underscore dataset. Whatever variable name you have given, that will be used here. Okay, and this dataset already has separated two parts. One part is training data, another part is test data. Now this dataset in Hugging Face is not in Pandas data frame. We need to convert them into data frame. So how to convert them? Now there are two subsections, or two I can say it's in terms of dictionary. So there are two dictionary values. One is train, another one is test. So just call IMDb dataset train dot to pandas. It will be converted the train dataset into pandas data frame, and I'm putting that in train underscore df. Similarly, test dataset, it will be converted into pandas data frame, and it is stored in test underscore df. Now if you see the training dataset first 5 rows, you see that is train df dot head. Now you will see the dataset is loaded and downloaded, and these are the 5 rows. Okay, I rented, I am curious, yellow, some sentence is there, label is 0, means negative, 1 is positive, whatever is there. Okay, and if you see, let's see a particular text, what is present in 3, this 3. So train df, the label is here, the sorry, the column name is text, so I am using text, and within bracket 3 means third row. So when you run it, you will get this is the data present, or this is the text present in the third row. That is, this film was probably inspired by Godward's Mosulin. Something is written, and you see in that text here these tags are also there. Many these symbols are there. So we'll deal with that. How will so first? What is our objective? Our objective is that how we can convert all the text, not this one, all the text present in that data set into lowercase. So for converting one text to lowercase, the simple way is that call that text dot lower, so it will convert this to the lower. Now you see this one is giving the third row, and if I apply dot lower, so this total text will become lower, because you see this t becomes small t. But if you want to apply this lower function to all the text available in this data set, what you do, you just call the train df on the text dot str dot lower. Means first you convert the series into, because this one is what, this is a series. Train df text is the column name, so this is series. On series we don't have lower function, so first you need to convert them into string. So dot str then dot lower. When you apply, and if you now print the first 5 row, you see I rented, so here I becomes small, everything becomes small. You see previously I was capital, curious yellow was capital, now you see curious yellow is small. So to apply this lower, means to all the data points in the data set, just use this one, just call the series dot str dot lower, it will become the lowercase. Okay, now as we have seen that this data set contains tags, and let's remove them, because the tags are not required, the HTML tags are not required, and we have seen how to remove them. So to remove HTML tags, what I have done here, I have created a function. Because you see what I am going to do, I am going to remove the tags from every sentence or every row in the data set, not from only the three. Okay, so that's why what I'm doing, first you create a function. It is a good idea. What you do now, here I'm importing a regular expression, and we know that this is the way to remove the, or this is the pattern to remove the tags we have already discussed in the last class. So what you do, you just create a re.compile, so that pattern is compiled and stored in the clean. So you just substitute this clean with nothing on the text. Whatever text is given here to this function, on that text you apply this substitution, this pattern, and replace that pattern with nothing. That means it will be removed. Okay, so let's run this one. So now the function is ready. Function name is remove underscore html underscore tags. Let's see, this is a text. Let's check whether this function is actually working or not. So this is a text. Here we have HTML head, everything is there. So if I call the remove HTML text and pass the text, now you see everything, doc type, HTML head, title, everything gone, only the text is there. Okay, now this is on the text, one text. Now if you want to apply this function to every text in the data set, what I have to do, I have to call the series train df text, then there is an apply function. Just call the apply and pass the method name. Here you see, just I am passing the name of the method. Which method? This method. And I don't have to pass the means this bracket, only pass the name on the apply. What it will do, it will apply this function on each data point on this series. Okay, and all this data point in that series will be converted, will be removed, or will be applied this one on this, and you will get the tags will be removed. So now you see, when you apply, you see there is no br. Previously it was br, now it's not, because I am only showing the 3. Similarly, or if you want to see 4 also, no problem. So again you will see here also there is no tag. Okay, so this is way you can remove the tag, already we have discussed. Now come to spelling correction, important spelling correction. So you don't have to do anything, there is a module available that is called text block. So you just call the text block function or import the text block function, and call the text block, pass the text, automatically it will correct. So you see here IPRONISE will BRESK. So when you run it, it will become PROMISE BREK. So remember, text blob is a function which can be used to convert misspelled word to correct spelled word. Okay, Now come to the fourth one, expanding abbreviation. So expanding abbreviation is very simple. What you do, you have to identify what are the abbreviations available in your data set. So that is a kind of job which you need to do, because there is no such functions available. What you do, you create a dictionary. Let's say here I have created, if it is I apostrophe m, then it will become I am. Can apostrophe t, it will become cannot. btw, by the way. You can write all such kind of short form and the corresponding long form. Create a dictionary. Okay, now what you do, you got a sentence, you just select each word, okay, each word from the text, and apply this one. So here you see, for word expansion in abbreviation dot items, then text equal to text dot replace this word with expansion, because word will be your key, expansion will be your what this one means the value, because this is key, this is value in this abbreviation dot items. Okay, so now you, if you apply, now previously it was I am, so it will become I am. Okay, btw, so this btw is by the way. Okay, so in this way you can increase this one. See whatever type, what type of abbreviation you have in your data set, put everything here and run it, it will automatically convert. And you can create a function for this also, and again you apply the same apply function on that apply method on that series, all this will be applied. Okay, now come to removing punctuation. So removing punctuation is also very simple. First, we have to identify what are the punctuations. So we have a function called string. Sorry, we have a module called string. In that module, there is a attribute called punctuation. So string dot punctuation contains all punctuations available in English. Now you see, if you just import string, string dot punctuation gives all such punctuation. Okay, if you want to exclude that punctuation, what I have done here, I am just putting this string dot punctuation in a variable called exclude. So now the exclude contains all these punctuation. What is my job? My job is to remove that. So here I have created one function called def remove function. I am passing text. So for char in exclude, that means whatever text you got, you will find out the character in the exclude one by one, and text dot replace char with nothing. That means if you got in a text any one of these punctuation, you just replace that character with nothing. That will be removed. Okay, so you run it. Now let's see, apply this one. Let's say hello, there are three exclamation mark, comma, then there is a dot. So forget this start time, end time. Remove punc, I'm calling that function, pass the text. So what you will see, you will see that the punctuation will be removed. Let's print it. Print remove punctuation text. We'll see only hello, welcome to NLP everyone. So all punctuation is gone. So now what I have done here, I am trying to find out, if I use this function, how much time it is taking to convert one text, or to remove one punctuation from a text. So that's why I'm giving a start time, end time, and subtracting the current time from the start. So it will give you this time. So 9.96 second is taking. Okay, but there is another function like this one. It is text.translate, str.make trans, then you just use this nothing with nothing and exclude. That means wherever you get a character in the present in the exclude, you just replace them with nothing. So this is another one, and if you apply this one, it will take less time. It is taking 9 seconds, rather it is taking 0.00. So instead of using this one, you can use this function, remove pump. And if you want to apply that on your data set, you just call the apply function, pass the remove pong function on this series. So on all the items of that series, this function will be applied. So from this, all data will be removed. Okay, now come to the chart word treatment. Chart word treatment is similar to your abbreviation. Here what you have to do, you have to create a dictionary. Like here U is U, GR8 is great, OMG is oh my god. Now you just create this such kind of dictionary, and just create a function. Here this function is doing what? Whatever text it gets, it find out, split that text into words, okay, and convert them into upper, because here I am using uppercase key. Okay, you whatever word you got, you just convert them into uppercase. If that uppercase value is present in chat words, that means the key, then you just append its corresponding value in this new text. Okay, else just append the original word, don't append this new text. Okay, and after that you join all the text, because the new text contains list, join these all words in the new text by space. Okay, so now this one is there. So if you have this OMG you are great 8, I am calling the chat conversion pass text, you see. Oh, this one I have not wrong. You see, you got oh my, so that means OMG becomes oh my god, because why? Because OMG is here oh my god, so it is replaced. You are, you is you, are is there, because all these things you have mentioned here, that's why it is working. Similarly, if you want to apply this one on the whole data set, you can again call the apply method, pass this chart conversion, automatically it will apply to all the data present in the data set. Okay, now come to the stop word removal. So stop word removal, there is a corpus in the stopword, sorry, there is a stopword list available in the NLTK corpus. So you just import them. So if you just see stopword.words English, all these stopwords are there in the NLTK. Okay, and you can do what? Now you can create a method or function like this, remove stop word, same, just whatever text you got, I guess, just first split it into words, and if that word is present in this stop word, so you just append nothing else, you append the original word, then, and after that you just join them with space, so you will get the new text without stop word. Okay, now you see, remove stop word I'm calling, I'm passing this sentence, I am learning NLP. So when you pass it, you'll see am is not there, I learning NLP. Okay, and if you want to apply the stop word removal to whole data set, same, just call the series, just apply and pass this function name. So what it will do, it will remove the stop words. Okay, so this is there. Now comes to emoji. Now for handling emojis, I need some pattern. So here these are the patterns. These you can directly use this one from U001F600 to U001F64F. All these emojis basically representing emoticons, different kinds of emojis. So all them I have just listed here in this remove emoji function. This is the pattern, and when you, and these are all Unicode format. When you got any emoji, you just substitute with nothing, means it will be removed. Okay, so when you run this one, let's say this is a text which contains two emojis, I call the remove emoji and pass the text, you see emoji is removed. This is one way. Another way is that replace emoji with the text. So how to do that? Very simple. You can create, one way is that you can create dictionary, emoji corresponding name, emoji corresponding name. Now you just call this text, and wherever there is a emoji, just replace it. Now you see, I love NLP with this is happy, this is fire. So when you replace it, it will become I love NLP happy fire. Or this is one way, manually you can do it. Or there is a module available called emoji. Just install that emoji module. So pip install emoji. What it will do, there are many functions available which will dealing with emojis. So just import emoji. Now there is a demojize function. What it will do, it will convert all emojis into its corresponding words. Now when I do this, you see I love NLP, this becomes smiling face with smiling eyes, means this is represented in this function, and this one is fire. Okay, either you can use this method manually, you can create a dictionary and replace it, or you can call the emoji module, and from the emoji module de-emojize, so it will be doing that. Okay, now come to stemming. So stemming, there are also two ways, either directly you can do, manually, or you can use a PhotoStemmer module available in the analytical library. For directly you are doing, you have to find out what are the suffixes. Now only this one is doing suffix topic, not prefix. Manually I am doing it. So take every word from the sentence and just assign this to the stemmed. If that word is present in the suffix, then you just if it is end with that suffix, then you just chop that last part, length of that suffix. Okay, length of that suffix. Okay, break, otherwise just up it. And lastly, you just join it, so it will become simple stemming. So now, if I have walk, walks, walking, and I call this one, it will all will become walk, and studying will become stud because ing will be removed. Otherwise, you can directly call Potter stemmer. Just import the Potter stemmer. Okay, and instantiate the Potter stemmer as a PS. Now you just take the text ps dot stem word for word in text dot. So that means you first you split the text for every word, apply that word on this ps dot stem. So it will every word will be converted to its stem, and all the word will be joined by this space. Now again it will become sentence. So now you see walk, walks, walking. If you call this one, it will become walk, walk, walk. Okay, so this is called a Potter stemmer use. Similarly, lemmatization. Lemmatization, directly you can create your own lemmatizer. It will be little bit tricky, but instead of doing that, you can use word lemmatizer, which is available in the NLTK. Okay, you just install the lemmatizer. But to lemmatizer to be used, we need to pass POS tags. Let's say running. So running, I have to find give that what running is what. Running is a verb. So POS is B. Better, better is an adjective. So POS is A. When you give this information, then it can give you correct lemma. Otherwise, it will not give you. So now if you run it, what it will do? It will give you the, it will take time. So you see how much time it is taking. Stemming is very fast, and this one is time taking because this will use this information and try to find out the root word. So you see better, I get good. But if you are using better here, okay, then let's say if you use better here, let's see what it is giving. It is giving same better stem words. Okay, so that means for better, this stemming cannot give you any root word, but here it is giving good. Okay, and for complete private, you just apply all them in sequence. If this is the text, I am applying lowercasing, then expanding, abbreviation, then chart word treatment, then your translate means your punctuation removal, emoji removal. All I have applied in sequence. You can do that, then you will get the final text. Okay, is there any doubt? So this much we have discussed. Only tokenization part I deliberately left it for the next class, and I have given some of the simple questions you can try. Yes, is there any question on any?
Yes, you can unmute and ask the questions. So one question, I think, in chat conversion, YouTube can be written as YouTube or YouTube. So
YouTube or YTube. So do we need to include both in the dictionary? Yes. You see, what is our objective? Our objective is that if I got a shorthand word and I know that it is not correct word present in any English dictionary, but I know what does it mean, what is its correct word. So you have to include everything in that dictionary. Okay. Otherwise, if you just use one word YouTube, which is YOUTU, but if you got YTU, then it cannot convert. So it is very simple. Just create a dictionary. How will create? How will know that which word to be put in that dictionary? No, you have to go to see the data set. So that's why in any NLP task or ML task, you should be very familiar with your data set. What is the content of that data set? Go everything by detail. Find out what are the short words available, and easily you can create a list. Okay. Okay. Is there any other question?
I don't think so. So tomorrow on answer at same time, na?
Yes, yes.
Somebody has given one query, Anurag.
Ari find all D1212 text printers are in last class. There was a question, extract dates. How to give date from 1 to 30? Oh, okay. You see here, actually in this case, here D is your 1, 2 means either it is 1 or 2. So actually, if you see, this will also give you a match with the 31st, 34, 35th, anything it can be giving. Okay, so to give you up to 30, again we need to think what should be the pattern. This is a very simple pattern. What it is written, that either the date digit will be either first day will be either 1 digit or 2 digit. Similarly, second, your month will be either 1 digit or 2 digit, and last year will always be 4 digit. But the problem with this is that if you have a date 34, also it is going to match. So our objective here is that we will match those dates, whether it is correct or incorrect. That is not our case. In a data, in a text, if somebody is written 34 December 34/12/2026. So if you see give this means this pattern, this that can be matched, even if that is wrong, but already it is there in the text, so we have to extract it. So to restrict between 30, again we need to explicitly mention the what uh, your digits. Explicitly you can mention the digits in the day part. It can match up to 30. You can write it, no problem. You can write it that if there is a 30 up to 30 it is present, it will giving you. If it is beyond 30, it will not give you. Okay, so here it means D12 means it is for a day, D4 means it is for year. 1, 2 means either it is 1 digit or 2 digit. 4 means it is 4 digit. So any 1 digit or 2 digit in day part will be matched. Okay.
Okay, sir.
And this is exercise. You try that how I can means confine my day up to 131 and your month up to 12. You can do that. You can create a pattern like this. Try.
Okay, sir.
Yes.
Okay then. So let us stop here.